Today we will study what is modulus of elasticity, equation for modulus of elasticity, and why are we determining modulus of elasticity, its applications in construction industry. Modulus of elasticity. It is an elastic constant of a material that represents a body's resistance to deform elastically under the action of a stress. It is also called as elastic modulus or Young's modulus. It was introduced by Robert Hooke. It is represented by E. This can be explained more clearly by considering a material that is subjected to tensile force by applying a tensile load of P. From the whole arrangement, I can determine the load acting on the body as P, the cross-sectional area of the body, say A, and hence the stress sigma is given by the load P by A. The strain is given by change in dimension by the original dimension. So this is the whole system of properties that can be derived from a material subjected to a tensile force or a tensile load. If so, if I increase the stress value, and I'm going to find out the respective strain for each increase in stress value. This method will bring a set of results or set of values of stress and corresponding strain based on which I derive a stress-strain curve. The stress-strain curve is derived for different materials for different load conditions. Here, let us consider a stress-strain curve for example, and the graph goes from O to A, then goes to B, then goes to C, D and E. All these points of the stress-strain curve represent different state of the material under different conditions of stress. So here, to explain modulus of elasticity, we are only concerned about the portion of the curve OA, where OA is the curve portion within which the stress is directly proportional to strain. The point A is hence called as the proportional limit. Regarding the points B, C, D and E will be explained in the later videos. So let's focus on modulus of elasticity. Getting a clear picture about stress-strain curve is very important to know what is modulus of elasticity. If I consider the curve OA, Robert Hooke have explained the definition as Hooke's law, which tells that up to the proportional limit for small deformation, the stress is directly proportional to strain. Hence, we can say stress is directly proportional to strain as per Hooke's law. Stress can be given as a constant into strain. Hence, this constant is considered as E or the modulus of elasticity of the material. Let us move into the interesting facts about what is modulus of elasticity and what exactly it means. As per Thomas Young, the value of E of any material is dependent only on the material and not on its geometry. That means E value of a small and a large piece of steel has the same value. E is a fundamental property of any material that you study and that cannot be changed, but it is dependent on the temperature and the pressure that is acting on that particular body. As I explained before, in the stress-strain curve within the proportional limit, the slope of the line within the proportional limit gives the value of modulus of elasticity. Now, what is the significance of modulus of elasticity? Now, elastic modulus allows to determine how a material responds to a stress. So, E is used to calculate how much a material would stretch and how much potential energy would be stored in it. So, it is a constant term that is related to the flexibility of the particular material. E is correlated with the deflection of many materials that is used in the construction industry. It is a major concern in the design of bridges and buildings, how flexible they have to be constructed. For example, if the E value of mild carbon steel is 200 gigapascals and that for aluminum is 70 gigapascals, it means that aluminum is 3 times flexible than steel. This means the carbon steel requires more stress to undergo any deformation. So this means aluminum is more flexible than steel. I hope this concept is clear to you. As a whole conclusion, let me tell you, a higher Young's modulus means a material requires high stress to stretch, and a material with the same distance as a material with a lower Young's modulus. So it's really important to understand any term in the civil engineering field, connecting it with the basis of real-time elements. So I hope this video was informative. For more information regarding civil engineering and to learn civil engineering with more ease, subscribe to Engineering Fanatics, Learning with Ease. Thank you and see you in the next video.